All right, first up in our examples to solve is this quadratic equation. It's written as 7x plus x squared is equal to negative 9. Okay, I'm looking at this square term. It's the largest power in x, so I do know that I'm using, it's going to be okay for me to use that quadratic formula to find its solutions. Now, right now, it wants us to find where the value of 7x plus x squared is equal to negative 9. Quadratic formula is not useful for this form. Again, we must write it in our standard form. So to do that, you're going to need to make the value on this right-hand side 0, and we're going to do that by adding 9 to both sides. And at the same time that we do that, we're also going to reorder these terms for us. So x squared, because we want that square term to come first, plus 7x plus 9 is equal to 0. And again, we have a positive 9 constant instead of a negative 9 because it's negative 9 on the right-hand side of the equal sign. So when we exchange its value to the left-hand side, we do have to make it positive. And so negative 9 plus 9 will get us that 0. All right. While you're getting really comfortable with your quadratic formula, I strongly encourage you to come over to the side and actually write out for yourself what those values for your A, B, and C are going to be. So A is actually 1. It's not written, so we can understand that it's a 1 coefficient. B is going to be the 7, and C is going to be our positive 9. So those are going to be the values that we're going to use to substitute into our quadratic formula. So again, quadratic formula tells us the value of the solutions. So it's going to tell you the values that would make our variable, when we subbed it back into that equation, equal to 0. All right, so let's start. We start with x equals, because again, we're solving here. So this already puts us into the form that we need for solving. X equals. And then we have, okay, we need the negative of b, which means the opposite. So 7 is positive, so we need to write a negative 7 plus or minus square root. Then we need to take that b coefficient and we need to square it, minus 4 times the a coefficient times the c coefficient. So filling in the quadratic formula, not too terrible. Where we see the most mistakes typically is with the negating b, and then also right here in the square term. Where the quadratic formula can kind of be of a kicker is actually in the simplifying process, because you don't get to leave it like that. You do need to now simplify. And we're going to use our calculator as a support to do that. So when I simplify with that quadratic formula, what I like to do is I like to use my calculator to help me evaluate the expression underneath that radical symbol. So it's going to give me a value, and then I'll go ahead and do that 2 times 1, which is going to give me 2. So I'm going to put this expression, just like you see it, that's underneath the radical in my calculator, using parentheses where I used parentheses before. All right, so 7 squared minus 4 times 1 times 9. And you guys know that I'm a huge advocate for when we substitute values for variables that we use parentheses, and that way if we need them, we have them, and if we don't need them, it's not a big deal. Our calculator can handle redundant parentheses. All right, so I'm going to hit equals, and that gives me the 13. So at this point, I have that my solutions are x equals negative 7 plus or minus the square root of 13 over 2. Okay. The only other step we now have to do is we have to see whether this radical will simplify. So that's going back into some of the work we did in 6.1 to 6.4, simplifying that radical by factoring. So we talked about there at the end that you can actually use your calculator as a support if you have this 30xs multiview in math print mode. So I just need to see if that radical will simplify, and it's going to return to me a square root of 13, which tells me it doesn't simplify. Same kind of thing with this calculator in terms of, will your fraction simplify? If it will simplify, it returns to you a simplified version. If it doesn't simplify, it just returns itself. So I know that this is the final form of my solutions to this quadratic equation. So what this actually is telling me is two things, that there are actually two values of x that will make this equation equal, have a value of 0. So the first one, x equals -7 plus the square root of 13 over 2. So that's my first solution. And then the second solution being x equals -7 minus the square root of 13 over 2. And we're going to leave it in that form because 7 is not divisible by 2, so we're not going to simplify any further. And I do want to remind you that this is a number. I could actually map it on the number line if I wanted to, with an approximate value, but this is its exact value. And because of that pesky radical symbol right there remaining in our answer, we have to conclude that these are irrational solutions, still real numbers, but they are irrational. So that's why their form looks so complex. It's just because in order to express these exactly with our equal sign, we're going to have to leave that radical notation involved. All right, we're going to go on to our next example now.